Okay, so this is question 4. Nasty question. The diagram is not terribly helpful. It says from a window in one of the SABC buildings. So we have a building over here, which is BD. And then we have a tower over here. And it says the angle of elevation to the top of the Brixton Tower. So this is the tower, TW. And the angle of elevation to the top of the Brixton Tower is alpha. And then it says the angle of elevation to the bottom of the tower. It really should say angle of depression. It would be much better to say angle of depression to the bottom of the tower. So it should be that one. That is also beta there because those are alternate angles. And then it says if the building and the tower are in the same horizontal plane and the tower is x meters high, so the tower is x meters high. And then it says to show that the distance between the building and the tower is this. So that's dw. So that's understanding the thing and getting the diagram for a start. So I'm just going to fill in beta over here, the alternate angle. Okay, so we've got two triangles. We've got this triangle here, which is a triangle BTW. And in triangle BTW, we've got an angle and a side opposite it. And we've got another right angle triangle, which is this one over here, triangle BDW. And basically we are trying to show that dw, so we're obviously going to need to work out what dw is equal to all of that stuff involving cosine alpha and cosine beta. And it says there's sine alpha plus beta. So that suggests very much that we're going to be working in this big triangle because then this angle B is alpha plus beta. So to get started with this, we're going to work in the right angle triangle. So I'm going to say BW is equal to well, we're going to work in the main triangle here. This angle over here, if this is 90 degrees here, if that's 90 degrees, then this angle over here is 90 degrees minus alpha, because this one is alpha. So in that's in triangle BT, and I don't know what we want to call that. Let's call that Y. So in triangle BTY. So we've got that angle over there. So we can do a bit of sine stuff. So in triangle BTY, we're going to say BW. So we're going to be doing this side over here, BW, over sine of 90 degrees minus alpha is equal to x over sine of alpha plus beta. So that's this angle here and its opposite side, and this angle here and its opposite side there. Okay, now you need to know that sine of 90 degrees minus alpha is equal to cosine of alpha, and you probably don't know that. So that would have made this very difficult for you. So sine of 90 degrees minus alpha is the same thing as cosine of alpha. So that's another identity, and I'll discuss it with you in class, and we'll make sure we know what that is. So I've got BW over cosine alpha is equal to x sine alpha plus beta. Now we want dw, so I'm going to just write all of that out. So dw is in this right angle triangle here. And you could use the sine rule, which is what they have used in the memo, or we could just use trigonometry. So we want, we've got BW, which is the hypotenuse. We want DW, and we've got B. So I'm just going to go cosine B. So I'm just going to say cosine B is equal to adjacent side, which is DW, over hypotenuse, which is BW. I think that's going to be easier than doing it the way that it's shown inside the answers. So then BW, we want DW. DW is going to be BW times by cosine B. And we've got BW. BW is this. I'm actually just going to finish writing it out. So BW is x cosine alpha over sine alpha plus beta. And so I'm going to just fill that in here. So I've got x cosine alpha over sine alpha plus beta times by cosine beta. And then if you compare them, this is the same as this, and it's done. Okay, so this is question 7. They've given you a formula for the area of a regular pentagon, and they want you to find the formula for the area of a regular pentagon. Should be quite obvious. You're going to use the little triangles, and there are 5 of the little triangles. So if we go over here, we're going to say that the area of each triangle is going to be half r times r, and then sine of whatever angle is over here. And that's going to be very easy. That's going to be 360 degrees divided by 5, so that's 72 degrees. So that's going to be sine of 72 degrees. And so your area, and then there's the area of the entire pentagon is going to be 5 times that sine 72 degrees. So nice and easy, and that's 5 over 2 r squared sine 72, and you should have done that and had it in terms of r. Then we want the area of a hexagon. It's going to be exactly the same, except this angle over here is now going to be 360 divided by 6, because obviously it's broken into 6 equal pieces. So that's 60 degrees. So the area of a single triangle will be a half r squared again, and then sine of 60 degrees. And then the area of the hexagon is going to be 6 times a half r squared sine 60 degrees. So this should be enough for you to now work out a general formula. So question C, they want you to work out a general formula for this, and you should have been able to see that the relationship here is going to be always our general solution. Just looking to see what wording they've got here. It says here, find a formula for the area of any regular n-sided polygon. So over here, when it was 5-sided polygon, then you times it by 5. When it was a 6-sided polygon, you times it by 6. So for an n-sided polygon, you're going to times it by n. You're still going to have a half. You're going to have r squared, because whatever size the polygon is, the lengths of the radii will be the ones that surround the angle. And then all you need is the angle, and the angle will be 360 degrees divided by n, because obviously that's the number of sides. So that's sine of 360 degrees divided by n. So sine of 360 degrees divided by n. And that's your formula. So n over 2 r squared sine 360 divided by n. So now we've got a general solution that will work for every single triangle. And they are asking us to work it out if you've got what was the question? If you've got a 10-sided polygon and each side is 8. So we've got a 10-sided polygon. Each side is 8, so that's 8. We don't know how big that is. It's a 10-sided polygon, so this angle here in the center is going to be 36 degrees, because you're going to go 360 divided by 10. So the area of our polygon is n over 2 times by r squared times by sine of 360 over n. And we know what n is. N is 10. So we have enough information to fill in n. N is 8. There's no problem with that. N is the number of sides, which is 10. And we just need to know what r is. We've got the angle. So we've got the number of sides is 10. So that's 10 over 2 times by r squared. And then this is going to be sine of 36 degrees. So that's easy enough. And we need to know what r is. We don't have r. We do have this pair here. And we have these angles over here. Because this is a triangle and it's an isosceles triangle. So those must be 72 degrees each. So r over sine 72 degrees is equal to 8 over sine 36 degrees. That gives you your value of r, which is 12.9 once you've worked that out. And then you're going to just plug that in here. So 5 times 12.9 times sine 36 degrees. And that is going to give you an area of 489 centimeters squared to 3 significant figures.